In today's lesson, we'll be interpreting quadratic relations. Many of the concepts today will be review, while a few will be new. In my first example, I have a quadratic relation in vertex form. The a value is -3, while the h value is +4, and the k value is -2. Let's take a closer look at the a value. Since the a value is negative, that means that there is a reflection in the x-axis. In other words, the parabola is now opening downwards, so it is frowning. Moreover, since the a value is greater than -1, that means there is a vertical stretch by a factor of 3. In other words, the parabola is going to get more narrow. Next, we're going to take a closer look at the h value. Remember, the h value determines if the parabola is translating to the left or to the right, and it is very counterintuitive. Therefore, since the h value is positive, that means the parabola is translating to the left by 4 units. And last but not least, the k value determines if the parabola is translating upwards or downwards. Since the k value is negative, that means the parabola is translating downwards by 2 units. Now that you've interpreted your quadratic relation, you can go ahead and graph it with a table of values as seen in our previous video, or you can use Desmos to graph it. I've gone ahead and graphed the base parabola of y equals x squared in Desmos, and I've also graphed the new quadratic relation, the one that has been transformed. As you can see, it is now opening downwards, so it is frowning. It is a little bit more narrow. It has been translated to the left by 4 units, and it has been translated down by 2 units. And the point that you really want to focus on is the vertex. And that's how you can tell if it's been translated to the left or to the right and up or down. Seeing the vertical compression or vertical stretch is a little bit more tricky, but seeing if it opens upwards or downwards is pretty obvious. At this point, we're going to describe the various properties or features of this newly transformed parabola. Locating the vertex is pretty straightforward. It is right over here, and the coordinates of that are -4 and -2. Now, if you didn't have the graph of this parabola, you can take a look at the quadratic relation in vertex form, and you would see that the h and k values correspond to the vertex. However, you do have to pay attention to the signs. Identifying the y-intercept should be pretty simple if you have the graph. However, if you only have a portion of the graph, as we do right here, that's going to be next to impossible. But we can do that mathematically, and you should remember that to find the y-intercept, you sub x equals 0, and you solve for y. In terms of the x-intercepts, if you have the graph, you can already see that there are no x-intercepts. So I'm going to put NA. However, if you did not have the graph, you can take a look at where the vertex is located, and you will conclude that since the parabola is opening downwards, there really wouldn't be any x-intercepts since the vertex is located in that quadrant. Next, we're going to take a look at the axis of symmetry. Remember, the axis of symmetry passes through the vertex. I'm just going to do a rough sketch over here. Remember that this is a vertical line, and the equation of a vertical line is x equals, and in this situation, it's x equals -4. Now let's take a look at the direction of opening. Since we have the graph, we can just look at it and conclude that it's opening downwards. However, if you do not have the graph, you can look at the a value, and since the a value is negative, that means it is opening downwards. So let's just write downwards. Next, let's take a look at whether or not our parabola has a minimum value or a maximum value, and that is in terms of the y values. Since the vertex is located over here, you just draw a little line over to the y-axis, and you can conclude that the maximum y value is going to be -2. Now, the last two properties or features of this parabola we haven't talked about before. So we want to determine what values x may take. If you recall, a parabola continues on forever. So there really should be an arrowhead both here and there, which indicates that these lines go on and on forever. So the values of x could be any real number. Which means if you take any value of x, you will get a value of y for this parabola. Later on in grade 11, you'll learn that this property is actually called the domain. And last but not least, we want to determine what values y may take. So we want to see what values of y will actually give us a value of x for this parabola. And you can see that the y values have to be less than -2. So I'm going to write y has to be less than or equal to -2. In grade 11, you'll learn that this property or feature is actually called the range. I'm just going to make a little note of that in case you're interested. That's called domain, and that is called the range.